Hello everybody and welcome back to another episode of Classic Arcade Repairs. I have a Space Invaders board set up on the bench. It's the Taito version, 3 board. And we got it all hooked up and it's not working, of course. This is one that I had repaired previously, and it crapped out, apparently. So it's back on the bench for another look at a new issue. You can see what I've done here. I had replaced a few chips on here, and my suspicion is some more stuff has failed as it has run. So a good place to start would be just to pop my 8080 pod. Oh boy. Somebody put the CPU in backwards. Yeah, someone was messing with this and put the CPU in backwards. Yeah, it's probably dead. It probably killed that CPU. Yeah. Oh boy. Okay. Well, let's grab a new 8080 and put it in right, with the right polarity and see what happens. Okay. Put a new 8080 in. And it is working, but it's got sync issues. Doesn't want to sync. Wants to roll vertically. So we can take a look at the sync circuitry and check the check the frequency and stuff like that, and see what our sync frequency is. But yeah, I could try putting this in the proper way, but it's probably not going to work. So yeah, probably killed that CPU. So let me do that really quick. I'll do that off camera. I'll just verify that this thing is dead, and we'll move on to the sync issue. Well, how about this? I put the old CPU back in it, and it works. So that is awesome. Okay, so let's figure the sync problem out. Alright, I will turn the scope on and we'll start poking around. Well, this happened. My hard drive crapped out in my HP 16500B. The hard drive died on it, so I'm replacing the hard drive, and while I'm at it, well, I was trying to mount the hard drive and one of these little screws fell down in this thing. So I had to take this completely apart to get that damn screw out of it. And while I have it apart, I'm going to take a little opportunity to get under the microscope and look at some solder joints and stuff. But yeah, this is my logic analyzer, and I'll blow everything nice and clean. Just kind of make sure everything's looking great when I put it back together. I'm putting a new hard drive in it right now. I have to modify the thing a little bit because this hard drive has a different connector on the back of it, so I have to modify the mount a little bit. And that's what I'm in the process of doing, and then I'll put it all back together with a new hard drive and reload all my software on it and everything. I have everything stored. I dumped every file off of the hard drive before and saved it, so because I knew eventually I was going to have to change the hard drive. So that's what I'm doing right now, and just kind of going over this thing, cleaning it up, checking out some solder joints, making sure everything's still looking great, and then I'll put it back together and move forward with my repair on the Space Invaders. Alright, I'll be back. And while I have the opportunity, some people have asked what my cards are that I have in here, and this is the 16550A, made in the USA. And I have two of them hooked together. You know, I have two of them. And of course I have the O-scope card. That's my CPU card. And that's the power supply there. So yeah. Alright. Just kind of show that real quick. Okay, well, what I found out, I got this thing pretty much all put back together. And what I found out was I had my hard drive, my modern hard drive, hooked with this adapter. It plugs into your hard drive right here and allows you to plug IDE in. This thing doesn't work with this. It won't recognize anything. So I have to come up with a different solution. I have some of these things for compact flash cards. I'm going to have to buy some compact flash cards and, you know, try that. Because, yeah. I think what I'll do is I'll get this thing set up to where I can just plug compact flash cards into it. And just use it with floppy drives for now until I get a card that'll work with it. So, yeah, these things are junk. This thing doesn't work. So I'm going to go ahead, I'll mount this thing in there. I just won't have no card in it. And I got this out of an old computer to plug into it. You know, old floppy thing. I'm going to use this. I'm going to cut this end off, splice this into this, and this will plug right into my original harness thing right there. This will plug into that, and then that'll adapt to this little guy right here. I don't want to hack anything on this. So, unfortunately, those hard drives, I just can't use them because I can't use an adapter. And I'm not spending $100 on an old hard drive for this, so it's just for it to fail. So, yeah, not happening. So, all right. Okay, and we are all back together. Except for the top, of course. And I've kind of got my little compact flash card thing just kind of zip tied right there. And it's powered. It's got the power hooked to it. It's just missing the actual card. So I can just pop the top off of this and when I get a card and put in there and see if it'll... From what I understand, these things are finicky and you might have to try a few of those cards before you get one that it'll actually recognize. So that's what we'll do. But in the meantime, I'm just going to run this thing off of the floppies. So, yeah. All right. Let's get back to, I forget what I was even doing. But, oh yeah, the sync. The sync on that Space Invaders. So, all right, let's get back to it. All right. Back to this. The customer that I did this repair for actually has two sets of these boards. And I repaired both of them, and both of them crapped out. This one, I had suspected, that one where the sync was going crazy, I kind of suspected that the CPU board, the ROM board, which creates the sync signals and stuff like that. It creates all of the vertical and horizontal counts and all that. This board. So I took from the other set. I took the board from the other set and put it on this set. And you'll see it is perfect. But this board set has sound issues. Has a sound issue. See, there you go. I noticed with the other board, as long as there was no moving objects at all on the screen, if it was a static screen, it would sync fine. But if there was anything on the screen moving, it would not sync. So I knew it wasn't a sync issue, so to speak. It wasn't just a flat out bad sync signal. There was something making it bad when stuff was moving around. So it had to have been a different circuitry that was affecting the sync, basically, is what I'm trying to say. But yeah, so this one is looking good. But it does have a sound issue. And I will demonstrate that. Let me pop this chip in here. This is a 556 in the thump circuit. The thump circuitry. Let me go ahead and put this camera up on the tripod and you'll see what the sound issue is. Okay, so I'll go ahead and start a game. This one plays great, but it's just the thump sound is not right. It's just weird. It goes weird. Okay. And you're not even going to be able to hear it. Hear that? It gets stuck on. I forget which is which. Anyway, you can't really tell what's going on there. It gets stuck on. The thump gets stuck on, so it's just something in that circuit. So I'm going to go ahead and fix this one first, and then we'll tackle that other one with this board, the other board. This one's got a sound issue. The other one might have a sound issue too. I don't know. But yeah, so I know this one has 174s, a 174 that activates each of the thump signals, and I think they get driven through an 07 maybe, and then these diodes right here are the diode, and the diode nut works for them. So I do have a disc here where I can fire this up, and I will be able to at least use the scope. I can't use the analyzer because I don't have that file on here, but we'll at least use that. And I did, by the way, I did buy a compact flash card for this thing. So, all right, while this boots up, I'm gonna go ahead and play another game. I'll be back. All right, with this set, I noticed that when I just messed around with my fingers, I would get random sounds. So I recapped up here. And to be honest with you, I can't believe that I didn't recap that to begin with. That should be a standard. On these boards anyway, they have to be recapped up here. So I did that, and it seems to have quieted right down, and it's not flaky anymore. So I'm just thinking that there were bad caps up here, and this board was not very stable as far as noise. I think it's quieted right down now, because I've been playing it and I haven't seen or heard any kind of wrongdoing. I turned the thump up a little bit so maybe you can hear it. I know it's this one right here. I can really turn it up for when I test it. So let's do that. I'll turn that thump way up and set up the camera and play the game. By the way, for those who want to know what I have gathered, this is the saucer that comes up on the screen. That's that sound. This is fire. This is invader hit. This is thump. This is saucer hit. So these two are the other two sounds. Crash, I think, might be this one. And I don't know what the other one is. We'll figure it out. But those are the ones I know. So let's set up the camera and play a game of this. All right, let's get it going. It's looking great. I'm going to put in a coin. Oh, nice shot. Ugh. 300 points. Come on. Yeah, dead. Let's play one more. Being that I'm just really not any good. Not a bad game for me. Yeah, I don't know if you, even if the camera's picking up the thump there, even though I've got it up loud. I'm sure it probably did. I'll go ahead and, yeah, there's a coin in there. Let's go ahead and start. And thump. Well, that's one down. Calling this one good. And then we gotta look at the other one, the other board, the other ROM board is bad. There's something funky on the other ROM board. All right, on to the second set. Okay, I got the second board set out on the bench, and this is that ROM board that causes the no sync condition. And this one had a bunch of bad stuff on it the first time that I repaired it. You can see I replaced all of these 161s before. I replaced a couple chips here and here. So there's obviously still some more bad on here, and possibly even a crystal, you know. So we'll, yeah, we'll look at it. But I just took this apart and noticed these weren't recapped either, so I'm going to recap this one as well. Yeah. And then I've removed this chip, the custom, and I removed the CPU because they were both really just black and tarnished, so I'm cleaning the tarnish off of those chips. And then we'll put those back in. I'm going to recap this, and then we'll be ready to fire this up, see what it does. We know it's not going to be syncing. It's going to be rolling and stuff. And other than that, we'll have to just see. These have all of the original 3900s. So that we probably, my guess is maybe some of the sounds crapped out. Who knows? We'll see. All right. We'll be back. All right. I hooked this one up. I did replace all the capacitors on this board. It's on the bottom here. And I got this thing hooked up. I cleaned the chips. CPU is nice and clean now. And turn it on, and oh, we just lost sync. Now it's not syncing. It was looking pretty good, and it just lost sync. But it ain't even running. It's static screen. And it's all wobbly now, just like it was before with that board. You know, with this board here. So, yeah. Look at that. Flaky, flaky board. Okay. Yep. Well, all right. Interesting. Okay. First things first, I want to get this thing running. We have a CPU board problem. First thing I'll do is just the simple thing and put in a different CPU. See if that does any good. If that doesn't change, then we'll put the fluke on it and check our RAM and ROM. All right, new CPU, same problem. On to the fluke. All right. So I can read my ROMs perfect, but I can't do anything else. So I started at the 241s, which are right here on the schematic. Those are the transceivers back to the CPU, and what they do is they basically switch between which line they want to come through. You can see the outputs are connected together because you have here line 9 is 1 bit, line 8 is 1 bit, and according to the select on this thing, it's going to select either one of those to come through. And I probed those, and those didn't look weird at all. Then I got to probing these guys right here, the 153s, and there's 4 of them, which make up 8 bits, which make up the 8 bits going back to these 241s and back into the CPU. Okay. Data is shared in these 153s. You have ROM data, you have RAM data, you have soundboard data, you have state data. Just all, 4 different signals are coming back and being selected. And if we look at the select bit, I'm just going to run this board. Run. Right now it is trying to run. See that? And if we look at the select bits, the 2 select bits on this guy, they're all shared. It's got 2 select bits. Is that the right chips? No. Sorry about that. These are the 153s. There's 2 select bits that come from this not OR gate. And they're all shared. They all come up here and they go to the select bit pins of those 153s. A is pin 14, which is the least significant bit, and the most significant bit of that 2-bit select is pin 2. So let's start by looking at A. Now keep in mind, this should be trying to select between those 4 different signals, right? Pin 14 is always low, right? What's pin 2 doing? Pin 2 is always high. So if pin 14 is the least significant bit and it's always low, and pin 2 is the most significant bit of that select and it's always high, this thing is always selecting 1, 0, which is 2 in binary. Well, if we look at this, what is on 2-bit? 2-bit is, this is the pinout of a 153. You have, this is the output, right? That's your output bit. And then you have, it goes like this, least significant, so it's 0-bit, 0, 1, 2, 3, and this is your select line. And this is just a enable, which is enabled low, and it's always low. So we're looking at, let's see what is on that 2-bit, which is what it is always selecting. Remember, this is the least significant select, which is 0, and then pin 2 is the most significant, and it's 1. So this thing's always selecting the 2-bit. So we have 0, 1, 2, which is pin 4. The 2-bit is pin 4 on this guy. What is on pin 4? Pin 4 goes ID6. So if we follow that down, follow this bus down, that is the instruction data bus. And the instruction data bus comes from all of the ROMs. So we can read our ROMs no problem, remember, because that's all that's being selected is ROM. Okay. Pardon me there for a minute. My son was just taking off. I was waving by to him. Okay. Where was I? Yeah, and the instruction bus is the only thing that is ever being selected here. So of course we can read ROMs no problem because that's all that's coming through these muxes. So we got to look at some circuitry that enables those. Let's look at this circuitry that is enabling these, that is selecting the data. Because we got no select business going on. It's stuck selecting instruction data. So if we come back, we see that this chip right here, which is a 02, you can tell by this schematic does not quite match up to this board, but you can tell that is a 02. I actually think this is a bootleg schematic, as it says Pacific Manufacturing Company. But it's the cleanest schematic I could find for a Space Invaders. It's a Space Invaders clone board, basically, is what it is. But it's the cleanest schematic I could find. So we need to look at this guy right here. Let's look at 2 and 3 out to 1, 11 and 12 out to 13, and 8 and 9 out to 10. And if we look at my little cheat sheet over here, right here, a NOT OR gate, you need 2 zeros to get a 1. So we need 2 zeros to get a 1. Let's check out that chip. It's this guy right here. This is the one. So let's start here with pin 3. Pin 3 is a 0. I'm going to move to pin 2. Pin 2 is also 0. Remember the truth table, you need 2 zeros to get a 1. So this output should be 1 all the time. And that's the output, and it is 1 all the time. Okay? So that one checks out okay. So now let's move to this gate right here, starting with pin 8 and 9 out to 10. Here's 8. Okay, this is pin 8, which is high all the time. So that tells me right there, remember the truth table, we need 2 zeros to get a 1. We're never going to have a 1 because this is never 0. So this output should be, no matter what the second input is doing, this output should be low all the time. So let's look at the next bit. This is pin 9, which is low all the time. And our output should be low all the time. And here's our output, and it is low all the time. Okay? So let's move on to our next gate in this guy, which is pin 12 and 13 out to 14. Here's pin 12. And pin 12 has an active signal on it. Okay, so let's move to 13. 13 is low all the time. Now, according to a truth table of a 02, you need 2 zeros to get a 1. And we do have zeros here. And we always have 0 here, so we should be basically buffering this signal. Or this should be inverting this signal, is what it should be doing. Because every time there's 2 zeros on here, you're going to have a 1. So every 0 on this is going to be a 1 on the output. So this should just be inverted. This is acting as an inverter. And our output is high all the time. That's the output. And remember, this should have a signal on it. You have a signal here on pin 12. 13 is low all the time. So this is just inverting this signal, and our output is high all the time. So that guy is no good right there. So if I go ahead and just pop a O2 over that, and let's try doing a rerun and check it out. There it is. So we will go ahead and replace that 02 proper, and then we'll check out all of our sounds and everything and make sure this thing, remember this is the board that was causing that weird jiggly stuff, and it seems to be absolutely solid right now. So I don't know what's going on there. But I tell you what I did do is I did recap this soundboard. You know, if you have a bad cap making waves on the power rails, that can cause weird stuff. I think I'm going to go ahead and recap these caps too. Replace those capacitors right there. Just for fun and good measure. But this thing looks perfect right now. Well, let me go ahead, replace that 02, replace those capacitors, and we'll be back. Okay. I replaced on the other board that 02 on this board down here. We got new caps here. I replaced the caps on this board on the back, on the front side of this board. Those yellow caps are new. I replaced those. Yeah. It's looking good. So let's go ahead, set the camera up on the tripod and play a game of Space Invaders on board set number 2. Okay, here we go. Coin up and start. I don't know if the camera's picking up the thump sound, but it is definitely there. It's just, you got to tweak the volume pots and the overall main volume and all that to really get it to where it's really thumping. But it's there. I don't know if you can hear it though, but it is there. I got baited. Coming back. Pretty cool. Well, that's Space Invaders repair times 2. And shame on me for not capping these the first time. That's something I should have done to begin with. Kind of scratching my head on that one. From now on, absolutely, these caps get replaced. You know. But yeah, so that was 2 of them. This one had a bad chip on it. And caps. And I don't quite remember what was up with the other one, to be honest. Anyway, that's two Space Invaders board repairs for you in one video. A 2-for-1. Because I love my subscribers just that much. Alright guys. Thanks a lot for watching. As always. Appreciate it. Space Invaders. And we'll see you all on the next Classic Arcade Repair. Thank you to all my patron supporters. I appreciate each and every one of you. If you guys are interested in helping support the channel and want access to some pretty cool stuff, we're getting a pretty good little thing going over there on Patreon. We're sharing some files and some PCB files and stuff like that. So check it out. Thanks guys, and we'll see you next time. Bye for now. Hey guys, well, this is a postscript, if you will. A PS. There was more problems. Basically what had happened is I was playing this and I noticed that the free man sound, just the beep 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 when you get a free guy was missing. So that ended up being I replaced the 556 timer on the soundboard because that produces that sound, and the other half of that 556 produces the thump sound. So it was a matter of time really before the thump failed as well. So I replaced that chip. That sound came back. And then I was seeing the wiggle again. Remember the sync problem? I saw that again. And I got to probing the crystal, and the crystal was kind of, it's a 20 megahertz crystal basically, and it was kind of jumping 22 down to 15. It was kind of jumping around every now and again. So I just went ahead and replaced that, and I haven't seen the wiggle since. So a couple of things I did since I ended the video was replace the crystal and fix the extended play sound. And it's been on for about 2 hours now without falter, and I've been playing it here and again, and it's working perfect. I just wanted to kind of chime in with that little bit of an update. So now we can call it good. All right, we'll see you next time, guys. Thank you for watching, and see you in the next one. Bye for now.